So let's talk about highest common factors and what a highest common factor actually is, and a neat little method that we can use to help us identify what the actual highest common factor between two numbers is. Now, to do that, we first of all need to discuss the word common factor. Now, common factor, we talk about factors of a number. Now, factors of a number is anything that divides into a whole number. Now, if two numbers can be divided by the same value, so for example, I've got 12 and 18 here, I know that 12 can be divided by 2, all right, and 18 can be divided by 2, all right? So both of these have a factor that's the same that they can be divided by. So we refer to this as a common factor. Now, the highest common factor is the largest number that both can be divided by. So whilst we know that both can be divided by 2, we actually also know that both can be divided by 3 and both can be divided by 6. So we've got the common factors of 2, 3, and 6, all right, for both of these. Now, you might be sort of looking at it going, okay, that's great if you're really strong with your multiplication skills and things like that, but we can now see between the two of them that 6 is the highest, so the highest common factor is 6. But how would we do it if we've got really large numbers that's not, I guess, quite so easy to identify? Well, it's where we actually start to use factor trees here to help us work through this problem. So if I look at a factor tree and try and list the number 12 in terms of all of its prime factors, we know it divides by 2 and we get a result of 6. And then we know 6 can also divide by 2 and we get a result of 3. So its prime factors are 2 times 2 times 3. Okay? We can do the same with 18. So 18 can divide by 2. It'll give us 9 when we do that. 18 can then be divided by 3 and it will give us 3. All right, so the number 18 can be represented as 2 times 3 times 3. And what we can see here is there's some commonalities between each of these, all right? We've got a 2 times 3 over here, and we've got a 2 times 3 over here. Now, if we actually do that multiplication together, this 2 times 3, all right, that there will find us our highest common factor, all right, which we know was 6. And that's essentially a neat little trick or a methodology that we can use to identify what is the largest number that divides into the two numbers that we have in front of us. So let's apply that to much larger numbers. So the number's 144 and the number's 300. Okay, now I look at these two numbers and I don't immediately just see a number pop in my head that divides into both of these. But we have a neat little method that can help us identify what the highest common factor will actually be. So what we want to do is we want to find all the prime factors of 144. So we start, all right, we know that 2 divides into 144, and when we do that, it should give us 72. All right, I can see 72 is also divisible by 2. All right, so that'll be 36. 36 is once again divisible by 2. So that'll be 18. 18 is divisible by 2. All right, so that'll be 9. And then 9 is divisible by 3. And that'll go 3 times. So 144, as a list of its primes, will be 2 to the power of 4, or let's just write them all out for now in expanded notation. Multiplied by 3 to the power of 2, or just 3 times 3. And now we can apply the same to the 300. So the 300 can be divided by 2. It gives us 150. 150 can be divided by 2. Gives us 75. 75 can't be divided by 2. It can be divided by 3. It can. So it can be divided by 3. And it'll go 15. No, 25. All right. 25 can't be divided by 3. It can be divided by 5, which is our next prime, and that'll be 5, and all those are prime numbers. So 300 can be represented as 2 times 2 times 3 times 5 times 5. And now what we want to do is we want to look at where do these sort of match up. So I can see here that we've got a 2 here and here. We've got a 3 here, and that's about it. We don't have any 5s that match. So our highest common factor should be 2 times 2 times 3. I'm just going to call it HCF for this. All right, now 2 times 2 is 4, times 3 is 12. So what we've just discovered is both of these numbers should be divisible perfectly by 12. And I can tell you they are. And this is a neat little method that we can use to find what the highest common factor is between these two numbers. Now you can easily see that both these numbers do have other factors. So, they can be divisible by 2, they can be divisible by 3. However, the highest number that we can divide both by and get a perfect answer, like, a whole number result, is 12. Okay, and that's how we can use factor trees to help us quickly identify what the highest common factor between two numbers are.